Today we are going to speak about potential energy. So in the case of potential energy, it is the energy stored in an object. It is the energy stored in an object due to its position, okay, due to its position or change in shape. Energy stored in an object due to two reasons. One reason, its position. Other reason, change in the shape. Remember one important thing. Now, this lesson, inshallah, I am recording, but it will be given as a private record. It will not be a public recording, public video, right? Only the students who are in this limit, okay, who are in this limit, who are attending this class, and due to some reason they have no way of continuing it, or some reason they will get that video. Okay, some might be there thinking, what's it? Sir will upload, no? I will use it. I will see that one. ඒගොල්ලෝ ලොකු අං දෙකක් තියෙන්නේ. හරි? එහෙම කල්පනා කරන කට්ටියට වීඩියෝ එක ලැබෙන්නේ නැහැ. Okay? You will not get that video. I'm pretty sure. I am marking the attendance here. I am marking your attendance. I know who is here and who is not here. Those who are here, refer this one. It was told several times, told in the class, if we are not in the group, be a part of the group, send a message. Okay, in that time they keep mouth shut up. Now they want the, okay, if they want the link, ask them to send me a private message now, immediately. Otherwise you send the link. No problem. They were told several times. Okay, so that is potential energy. Energy stored in an object due to its position or change in shape. Are you given this definition already? Are you already given this definition in the tute you have been provided? Yes. So no need to copy it, right? Here, in the potential energy, there are two types of potential energy. Now this is a spring. If you tighten this spring in this manner, because you are tightening it, because you are tightening it, it is storing energy in it. Because you are tightening it, it is storing energy in it. The energy now in it, the energy now in it is potential energy. Is there any movement here? Is there any movement here? Do you notice any movement here? No. But it has energy. It has energy. If it is moving, it would be kinetic energy. Now it is not moving. So, but it has energy. If I release it, what it will do? What it will do? If I release it, what it will do? It will jump away. It will jump away. This unit I have it for the grade 7 class to teach them potential energy. Now see, okay, once you release it, it will cut the hand. Very carefully we have to handle it. Okay, so it is potential energy. Similarly, if you take a rubber band, now at the moment rubber band doesn't have any energy. If you stretch this, now it has energy. If you release it, it will jump away. That says us it has energy. Are you clear? Are you clear? Right? So the energy, the potential energy, what we shortly mark it as EP. EP is potential energy, can be divided into two. One, it is elastic potential energy. Elastic potential energy. In the case of elastic potential energy, it is due to change in shape. What are the examples? Energy in stretched rubber band. Energy in stretched rubber band. Energy in coiled spring. So that is what kind of energy? Elastic potential energy. Another kind of potential energy is there. It is called gravitational potential energy. Gravitational potential energy. Right? It is due to height from Earth's surface. It is due to height from, what is it? Earth's surface. In that case, my children, if this is the Earth's surface, if this is the Earth surface, when the object is on the Earth, we take the potential energy is 0. You are standing on the land. If you are standing on the land, your potential energy is 0. When you stay above the land, now your potential energy is greater than 0. When you go and stay taller than this position, here the potential energy is much greater than 0. So, if you go to taller places, what is happening to the potential energy? If you go to taller places, what is happening to the potential energy? Potential energy is increasing. So that is gravitational potential energy. Can you understand that there are two types of potential energies? Can you feel the differences between those two? Rubber bands energy, stretch potential energy. Coils energy, stretch potential energy. Stretch potential energy is okay. Stretch potential energy is okay. Right. Gravitational potential energy depends on which factor? Gravitational potential energy depends on which factor? Can somebody tells me? Gravitational potential energy depends on the height from the Earth's surface. If you go to taller places, now say one person stand in the first floor of a building, another person stand in the second floor of the building. Who has more potential energy? Namira, can you answer me? Who has more potential energy? One person in the first floor top, other person in the second floor top. Who has more potential energy? The person in the top of the second floor. More and more the height, okay, there will be more potential energy. Are you clear? Are you clear? Hope you are clear. Right? My children, keep one in the mind. Now, there are points that pointing that own line is not effective than live classes. Those kinds of things are there. Now, in Akurana, there are very nice fast food shops. Okay, mainly Kiaso is one of the most nice fast food shop. When you are having freedom, you can choose the best fast food shop and go for your dinner. In the lockdown period, when you were not able to get out, what you were eating. Chaos of food. Chaos was distributing to you. So point is, there's always a proverb. Something is better than nothing. Something is better than nothing. Understood? So actually, the online session would not, sometimes it will not really, the person is not in direct. Okay. But you have certain opportunities here. One, your time is not wasted. Okay, because after 1 week or 2 weeks time, again, if they start the classes, even your classes have been conducted already, your syllabus have been covered already, so that benefit is there. Second thing, now in this medium only, I notice the students ask questions. I can see the personal response of the students. Okay, there are some in the live classes, some voices will be peak and some voices we never heard. It's true, right? Some voices will be in peak, their sound only coming out in answers, others they don't. So everything has some good and bad. So the thing it is, we are not emphasizing 100% online classes, but thing it is, in situations without telling reasons for I'm not happy of it, my what's it, in connection has problem, without bringing reasons, try to involve in it and get benefit of it. I also can sleep by like other teachers without doing this session, right? But I don't want to do so. Right. So hope all of you have understood it. It's a very simple idea. When you go tall, what is happening to the potential energy compared to this height? This height has more potential energy. Compared to this height has more potential energy. When you go become tall and tall, your potential energy will increase. Rifat, Rizwan, can't you understand when the tall, the height is more, the potential energy is more? Okay, my children. So although it is in the note, you take a briefing here in a white sheet. You take a briefing of this. Okay, you take a briefing of this. Then put me a done mark soon. You complete it. I can go to the next. Good. So my children, in this lesson, although there are two types of potential energies, calculation wise, we have only one. We are going to calculate calculation of gravitational potential energy. Calculation of gravitational potential energy. Okay. If you want to calculate EP due to the height, this is the formula. Mass multiplied by gravitational acceleration multiplied by gravitational acceleration multiplied by height, that is vertical height. Vertical height. They used to call it height. Better you take it as vertical height. Okay. So what is the formula? Potential energy equals to mass multiplied by gravitational acceleration multiplied by vertical height. We can symbolize this one by simple M. We can symbolize this one by simple G and symbolize this one by simple H. Then automatically the formula comes as EP equals to M into G into H. Okay. In this case, the mass you have to use in kilogram. You cannot use it in gram units. This is always coming in ms minus 2. That is not necessary. And the height should be mentioned in meters. Mass should be used in kilogram. Height should be used in meter. Then only EP will come to you in joule. Okay, if you want the EP value in joule, mass should be used in kilogram, height should be used in meters. Right? Are you clear? Are you clear? Right. So if you are given this equation already in the tube, you mark the other details there and complete it. You mark the other details there and complete. Okay, put me a done mark. You have less work there. You have less work there because the equation is already written to you. Mass into gravitational acceleration into height. The other thing only how to mark. M is marked in simple N. This is G and this is H. This is measured in kilogram. This is measured in meter. Then the equation comes. Right. If that is done, you child go to the first question. Answer the following question. First question is find the gravitational potential energy of a mass 7.5 gram with a vertical height 4 meter. No, Zaid, I will not upload. Why Zaid? Why should I upload it? You are here now. Zaid, you are here now. Why should I upload it for you? Put it to charge. Stay near to the charger. Right. The first question, easy question. Though it is an easy question, if you want full marks, you have to do it in the proper way. EP equals to MGH. That you have to write first. Then you are substituting. EP equals to, substitute in this manner. That is the best method of substitution. 7.5 kilogram multiplied by 10 ms minus 2 into h. How many meters? 4 meters. Now you multiply, get 300 answer. EP has a unit, joule. 300 joule is your answer. Okay. Do the second question. This is the answer for the first question. You try the second question. Don't expect any uploads from here. Okay, for your, okay, you stay. If you stay, I will upload for you. If you stay, I will upload for you. If you leave, I will not do any support to you. Adil Shyam, I don't know. Your cousin also have the same problem. Adil Shyam, your cousin also have the same problem. I think it's a family problem. Right. Second question, a fruit Here also you have to write this formula once again. EP equals to mgh. You know who is your cousin? Your cousin sister. Right. M 200 gram. 200 over 1000. You have to write it in kilogram. Gravitational acceleration. Now this is in kilogram. Gravitational acceleration 10 ms minus 2. Height here also 4 meters. 30 cancelled, equal to 8 joule. 8 joule is your answer. Do the third question then. First, second questions are okay. First, second questions are okay. Do the third question. Third question has 2 parts there for you. Third question has 2 parts there for you. One by one, do the answering. I am erasing this one. First question, second question done. So I am erasing it. Question number 3. It's an important question for you. So that question, I'm going to tell you an important idea. That's why that question is given to you. Every question is so there. First question, you are applying EP equals to mgh. Second question tells you, though gram is given, you have to use it in kilogram. Third question is going to teach you another idea. They are not just questions to do one after the other. Through one question, you have to learn something. Then only that question is worth. Otherwise, that question is not worth. Put me a done mark or type your answer. Only few people have yet responded to me in the third question. Ruzman has responded to me. Type your answer. Type your answer. I want to see that answer. How much you have understood it. Third question, part 1, part 2 answers I want. Third question has 2 parts, no? Both the parts answers I want. We'll see your work. So you are not, in the second question, you are not asked what is the name given for that. You have to write what is the value of that energy. Some people write for second answer, what is the potential energy stored in the object mean? Gravitational potential energy. It's not the thing expected from you. You have to find the value of that energy. Second one also, you have to find the value of it. First one also, you have to find the value of it. It's a calculation based question. Right. I think most of you have forgotten what you worked on last class. In the last class, I worked how to find out work. I gave you the answer work equals to force multiplied by displacement. In that case, I told you, when you are lifting an object, in lifting an object, say you are lifting an object. I told you this. You have to use weight as the force and height as the displacement. Even I did questions using this. Can you remember? In the first page. In the first page, I did it. So, here you are given. Here you are given a 2 kilogram object. What is 2 kilogram? It is the mass. So the mass is 2 kilogram. Mass is 2 kilogram. That is not weight. We have to find the weight. Weight equals to mass into gravitational acceleration. Weight equals to mass into gravitational acceleration. So, mass is 2 kilogram, gravitational acceleration is 10. So, weight is equal to 20 Newton. Weight is equal to 20 Newton. It is this weight we are going to use as the force. Height. Height you are given. Height is given to you as 8 meters. So, the work done is force 20 multiplied by displacement 8, 160 joules. How many of you got this answer? First question answer. Some of you have used 2 kilogram. 2 kilogram into 8 and got 16. But you say that you are very clever. This is your first question answer. Keep in the mind, not 16 joule. When you come to the second question, calculate the potential energy. It is EP equals to mgh. So EP equals to mass 2 kilogram, gravitational acceleration 10 ms minus 2, height 8 meters. It also will give you 160 joule. So from these calculations, what is the decision you can come regarding these two? What is the decision you can come regarding these two? Okay, this is the final decision. In lifting an object, work done is equal to potential energy. Sometimes they might give you the potential energy and can expect you to do some work with work done. So from this portion, you are learning this. In lifting an object, work done and potential energy, they are same. They are not different. You have to mark this point. If they give you work done, you can use it as potential energy. If they give you potential energy, you can use it as work done. Are you clear? Shall I go to the next heading? Okay. Now, remember, now the next heading it is, how can we get benefit of, the potential energy and the kinetic energy? How can we get benefit of the potential energy and the kinetic energy? Right? First thing is we study in our lower grades even. In the manufacture of hydrolacticity, we use this. Okay, you had it in the grade 7 or something. In it, there will be a reservoir having water. Are you shown in the diagram the reservoir? Are you shown in the diagram the reservoir? Yeah, it is stored water. If it is stored water, what kind of, and it is located at the top of a mountain. Two things are there. It is stored water, not a moving water. Second, it is located on the top of a mountain. What kind of energy is present in it? It is potential energy, gravitational potential energy. So the lesson starts with this one. In the beginning, when the water is in the reservoir, there is gravitational potential energy in water. right? Now, from the reservoir, you can see in the picture, there is a tunnel. Through this tunnel, water is made to flow down. Can you see that tunnel in the picture? Can you see that tunnel in the picture? So, water is moving. Water is moving. What kind of energy is there? Moving water, moving water, moving down, flowing. What kind of energy is that? It is kinetic energy. So, my children, here we say there is an energy transformation. Gravitational potential energy turns to kinetic energy of water. Okay, the water falls on a turbine of this manner. The water comes and falls on this turbine. Because it falls on the turbine rotates. What is the energy now in the turbine? What is the energy now in the turbine? The turbine is rotating because water falls on it. The turbine is rotating. What is the energy stored in the turbine? Right, so that is kinetic energy. So kinetic energy of water becomes kinetic energy of turbine. Because the turbine is connected to the generator, generator functions and give you electricity. Generator functions and give you electricity. Are you clear? Are you clear? Is there any place that you are confusing? Good. So under the picture, I have left a space for this flow diagram to be completed. Okay, I have made a space for flow diagram to be completed. Complete it. And put me a done mark soon you complete. Good, good. Okay, my children. The second it is another application. It is easy application, but they just tell you a longer thing there. It is regarding a pile driver. Pile driver, this is a pile. The bottom end of the pile will be this way. Think like a pillar. You want to fix this pillar into the ground. It has to go into the ground. Now you have seen Kadugasthotta bridge. Kadugasthotta bridge is built on a pile. It's a deeper pile there. It is holding all of us. It is holding all of us, the pile. Now, how do we send this pile down? It's very deep we are sending. Here we fix a pile driver. Very simple. Very simple. We keep a pile driver. We outside make a cover. Here we have a very heavy weight here. Though I am drawing small, the heavy weight there. This weight we lift it up and release it. It come and hit. Again lift it up. Release it. It come and hit. Again lift it up. Release it. It come and hit. Every time it hits, little by little, this pillar will go down. Are you clear? Simple idea. This is the one. We raise it and put it on it. Again, lift it, release it. Release it. Okay, right. So, here, when you are lifting, you have a kinetic energy of the pile driver. The top portion you are lifting, that is the pile driver. When you hold it in the last, you are holding it in the last, no? Now it becomes potential energy of pile driver. After holding it, you release it, no? Potential energy of pile driver. After holding, you release it, no? You release it. It's coming down. That means it is again kinetic energy of pile driver. Okay, because the pile driver hits the pile go down. Okay, pile is moving down. Kinetic energy of pile. Are you okay to accept this flow? No, you can say gravitational, why can't? You can say gravitation, no problem. I'm a person very lazy in writing things. Then second, it is as it is online, the children want it to be written very clearly. The children want it to be written very clearly to see the board. Maximum I am writing with my clarity. My handwriting is very, very poor. Okay. So You are, now you want to, this is the pile. You want to make it Seema. You want to, others copy it. Seema, you want to put this one down. You are lifting it up, Seema. What is the energy now in it, Seema? Moving up. Okay. When you stop it here, what is there, Seema? When you release it, what is there, Seema? When you release it, it comes and hit here. You are releasing it. When this one hits, this is moving down, Seema. What is the energy of this one, Seema? That's what I written, Seema. Okay. Completed pile driving. Okay, the third one, how do you use a sledgehammer? So here is the sledgehammer, right? You are lifting the hammer. You are lifting the hammer. What is the energy? You are lifting the hammer. What is the energy? Lifting. You are lifting. Your hammer is moving. Your hammer is moving. What is the energy? Kinetic energy. Finally, it stays here. What is the energy? It stays here. Potential energy. It is moving down. It is moving down. What is the energy? When it moves down, the nail is moving in. So it is the kinetic energy of the sledgehammer. It is the kinetic energy of the sledgehammer. Finally, it is becoming the gravitational potential energy of the sledgehammer. Then it is becoming kinetic energy of the sledgehammer. Finally, it is becoming the kinetic energy of the nail. I used a pen, but actually it is a nail, right? A nail is driven. Thinking this is a nail, the physics behind this is kinetic energy, potential energy, kinetic energy. Quickly, there's a change. Clear? Good. Complete it. Sledgehammer. Okay, good, good. So now we are coming to an important idea. All of you have to very carefully concentrate on the next idea. The next idea is very, very important. Right. The next idea here is say you are throwing an object from Earth's surface. You are throwing an object from Earth surface. So this is the Earth surface. Here you are having an object. You throw this object upward from the Earth surface. At this point, can you tell me what about the potential energy of it? I tell here it has a mass 2 kilogram. What is the potential energy of it? Its potential energy M into G into H. 2 into 10 into 0. If you multiply a number by 0, it will be 0. 0 joules. Do you agree with it? Do you agree with it? Good. You are throwing it with the velocity 2 ms minus 1. You are throwing it with the velocity 2 ms minus 1. If so, there is a kinetic energy for it. What is the formula for kinetic energy? Half into mv square. Am I right? Am I right? Right. That is half into m 2 into 2 square. That is 4 equal to 4 joule. Right. Now, this is moving upward, upward, upward. Finally, it will come to a stop. Do you agree it will come to a stop? Do you agree it will come to a stop? If you throw something upward, will it go continuously up? If you throw something upward, will it go continuously up? No, no. In one place, it will stop. So, do you agree it will stop? So, in this stopped mean its velocity is becoming 0. Do you agree? Do you agree? Its velocity is becoming 0. That is why it is stopping. Am I right? So, in this position, if you calculate its kinetic energy, if you apply half mv square, half into 2 into 0 square will be 0. So it is going to be 0 joule. Agree with it? Agree with it? So when you have moved upwards, what has happened to the kinetic energy? When you move upwards, what has happened to the kinetic energy? So here we decide kinetic energy decreases. Do all of you agree with it? Good. In this case, now when it is moving here to here, how much the losing the kinetic energy? Losing EK, how much? It was 4 joule in the beginning, last it is 0. How much the loss in the kinetic energy? Loss in the kinetic energy is 4 joules. Okay. Now, when it is moving up here from the earth, when it is staying here above the earth, when it's staying here above the earth, when it's staying here above the earth, when it's staying here above the earth, what is happening to its potential energy? It stays here, then stays here, stays here, stays here. Potential energy increases. Now, this height, according to this, will be 0.2 meters. How much the height? 0.2 meters. Okay. If so, let us calculate the EP. M 2 kilogram, G 10, height 0.2. How much? How much? Four joule. So here to here, what is happening to EP? EP increases. How much the gain in EP here? Gain in EP, how much? 4 joule. Can you understand what I am trying to prove you here? Can you understand what I am trying to prove you here? No. The first thing I have to prove it is, okay, in the beginning, what is the kinetic energy? The three things I have to prove here. In the beginning, what is the kinetic energy? 0. In the last, sorry, in the beginning, what is the potential energy? 0. In the last, what is the kinetic energy? 0. In the beginning, what is the kinetic energy? 4. In the last, what is the kinetic energy? Right. So this is the final thing I want to come. All the EK at the beginning, all the EK at the beginning equals to EP in the last. That is one thing I want to justify here. Another thing I want to justify here is loss in EK equals to gain in EP. Loss in EK equals to gain in EP. Do you agree with these two decisions? Do you agree with these two decisions? In the beginning, 4 joule kinetic energy mean in the last there will be 4 joule potential energy. That how much the kinetic energy is lost, that much the kinetic energy is gained. Are you clear? You copy down this. Put me a done mark soon you complete. Good. Shall I erase it? My children, shall I erase it? Any one of you still write? Okay. Now the same story in opposite. When an object falls down from rest. Now, for example, on the top of this board, I keep this pen. Okay, now it is in rest. And now it is in rest. Falling down. Falling down. So when this object is at rest, then you release it, it falls down, 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 and reach the earth surface. It moves down, 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 and reach the earth surface. We are going to work on the idea. If you have understood the earth, the idea here, the previous idea, this will be easy for you. In this place, if there is a potential energy here, 100 joule, what is the potential energy at this place when it touches the ground? The potential energy is going to be 0. What is happening to the potential energy? What is happening to the potential energy? It is decreasing. As it is at rest, the V is equal to 0. That means in EK half mv square, V is 0. Then what can you tell about EK here? Half mv square, in that V is 0. What can you tell about EK here? EK here is 0. So in the previous one I told, now here EP decreases. What is the loss in EP? Loss in EP equal to 100 joule. What can you tell about EK when you go down, 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 down? What will happen to the speed? What will happen to the velocity? The velocity will increase. If so, when it is touching the ground, will there be a kinetic energy? Yes. Losing EP. Last time I told losing the kinetic energy is equal to gaining the potential energy. Did I tell you that? Did you mark it? If so, here loss in EP I have marked, loss in the potential energy I have marked. What shall I mark here? Loss in EP I have marked. What shall I mark here? It is gain in EK. That is how many joule? 100 joule. What is happening to EK? EK increases. So when the object touches the ground, its kinetic energy will be 100 joules. Are you clear? Are you clear? I am maintaining a mild pace to make everyone to understand it clearly. Okay, don't go and complain. I am doing this one slow. I know how to do things fast. Are you clear? So this is when an object is falling down from rest. Copy down this and put me a done mark. Okay, so that is enough for the day. We'll meet on next class. Allah wishes, we'll meet on the live class by next week. Jazakallah khair. Assalamu alaikum.